Here we go. We're recording. So remember, hyperbola, if you have a hyperbola like this, right? Remember, that's C, right? And that's A. So C over A is going to be 5 over 4, or 1.25. Fine. Whatever that means, we'll deal with that later. No x-intercepts. This graph is not going to cross the x-axis. This is where you got to think critically now. You're not going to cross the x-axis. Is your parabola, sorry, is your hyperbola vertical? Vertical. Yeah, it's got to be vertical. Now, vertical could cross the x-axis, but the way I just drew it would not. If you're sideways, guaranteed you're crossing the x-axis. Regardless of where you put it, it's going to hit it eventually, right? Because it's going up and down forever. The range is all real numbers, right? Think about the range. Range is all real numbers for sideways or horizontal hyperbolas. But for vertical hyperbolas, the range is not all real numbers. It's limited. The domain's all real numbers, not the range. So that's totally, so this tells me this is vertical. Okay, that's good. Okay, the area of the central rectangle equals 48. Well, the central rectangle, when you graph these, right? I'm going to do another quick sketch here. There's a central rectangle in the middle, right? I just repeated myself, but anyway. So that's A, right? And what's that? The horizontal distance there. B. So what are the dimensions of the box then? It's what by what?
Well, like 2A.
Yeah, 2A. So now I know 2A times 2B equals 48, or A times B equals 24. That equals 12. Okay, I think we're on to something here. A times B is 12. Okay, we're on to something. I do give you the coordinates of the bottom right corner. Okay, let's do it. 2, -6. Okay, 2, -6. So it's like a puzzle. Okay, 2, -6. I got that. Okay, cool. So here's the deal. C over A is 5 over 4. A times B is 12. Also, we know this is true, right? That's a true statement. So what do you think A, B, and C are going to be? What do you guys think?
I would say 4, 3, and...
Yeah, I like that. Good. So I'd say this is probably 4. That's probably 3. That's probably 5. That's probably 4. 5 squared is 16 plus 9. Yeah, I like that. Okay. All right, we're getting somewhere now. All right. So, and it's going to be vertical. Okay, it's going to be vertical. Now, this is where you got to be a little careful. So, it's actually going to be like this, right? The central rectangle, that's 2B, and that's 2A. Because remember, A is a distance from the center to either vertex. So A is actually going to be vertical in this case here, and B is going to be horizontal. The other way is to know it, right? Okay. All right. So my A is going to be 4, and that's the bottom right corner. So I'm going to have to move to the left to get the other corner, the bottom left corner. How far do you think I'm going to move to the left? 6, yes. Because you got these 3. So the center's right here. 1, 2, 3. I agree. How far do you think I'm going to move up from the bottom right corner? Yeah. So we'll go up to +2. And the center, sorry, is actually going to be, I don't know why I drew that dot there. That was dumb. The center is probably going to be -1, -3, I think. No, -1, -2. Okay. Is the area of this box 48? You bet. 6 by 8? Totally. Are there no x-intercepts? Totally. Is C going to be 5 and A is going to be 4? Totally, right? Bottom right corner. I like this. This is good. I think we've got this now. Yeah. No, that's for no, it's always for the fract. So it's always for how it opens. You think of ellipses. Actually, for ellipses, it doesn't matter. A is always for for an ellipse, A is always the biggest, the major, right? For hyperbola, it's always going to how it opens. So it's opening up and down. So it doesn't have to be for X or Y. We don't know. Just depends how it opens. So we never want to think of that way. Now I can write the equation, right? I think we're We're all set.
Wait, also here, it can't be up 6. Because,
Yeah, exactly. So so I'm gonna have y minus y plus 2 squared over, and it's going up and down 4, so 16, minus x plus 1 squared over 9 equals 1. There we go. Yep. And there's my hyperbola. So that's the kind of, would this take you about maybe 10? I think this would take about 10 minutes, maybe. I don't know, maybe it might take you longer. But it just gets you thinking a little more analytically, right? Like a puzzle. So you know, you got to put the pieces together, the puzzle. So, dude, good.
test would also be like simple numbers that can be.
Of course, yeah. But I'm gonna think of something creative. I'm gonna think of something that you probably have not seen before. I will have some stroke of creativity. Some of this hit me this weekend. So maybe when I'm out with my kids for Halloween stuff. Some of this just hit me. So all right.
You were like creative problems.
Yeah. All right, let's look at the other one here, guys. Now, we have a homework check-in today. We have a homework check-in. It's actually very similar to this problem here. Very similar to this problem. So you're actually gonna, so you guys actually should be fine the homework check-in because I'm kind of giving you what. And this is true. This is the Gateway Arch in St. Louis, Missouri. I think it was built for the World Fair like back in the mid 20th century. Actually, never been to St. Louis, but actually, if you guys, I'm not sure you guys know, the first ever Sacred Heart School that opened in the United States, continental United States, was actually St. Charles, Missouri, right next to St. Louis. Yeah, that's where St. Rose Philippine Duchesne, one of the founders, started school there back in the pre-Civil War era, if I'm not mistaken. Kind of cool. Okay, I'm gonna do it like that. I'm gonna make this a parabola that opens down. So the equation will be kind of like this: x minus h squared equals 4p y minus k. But it's pretty clear h and k is what? Pretty clear it's 0, 0, right? So it's x squared equals 4py. Now, you're given dimensions, right? You're told the dimensions are following that it's 630 feet wide at space. So it means that this is at 315, and that's at negative 315. So this dot right here, this dot right here is 315 comma y, and that's negative 315 comma y. Okay. Also told the height of the arch is 16 times distance between the vertex and the focus. Okay. So if that's p, no, it'll be 16p. Yeah. So actually, I could change those y's to p's now. Oh, yeah. Okay. So that's going to be negative 16p, negative 16p. Okay. Actually, the p's are going to be negative as it is, so let's just make it 16p because it's going to make the math cleaner. Let me make it just 16p because the p is going to be already negative as it is because it's going down. So I'm going to plug in 315 for x, or negative 315, your choice, 4p times 16p. And now you're going to solve for p. Right? So I need to calculate this. 315 squared is, and the answer is pretty impressive. When we see how and the engineering was actually pretty cool. Like went into this. So p squared is some crazy number. 1550.390625. If I square root that, what do I get? 39.375. But what's the question asking for?
The height.
The height. Well, when these other like word problems, like, oh, give me the equation, blah blah, those are lame questions. This is cool, like, because you actually see this is the real thing, right? So, right, the height is going to be 16p, or what's that times 16? 630 feet. So the height is the exact same dimension as the width of the base. Kind of cool how they designed that. So the height's 630 feet, and look it up. This is true. 630 feet of the gateway arch. I don't know. And I didn't get my degree in construction. I don't know. So, but anyway, that's how you can work out those kind of problems. So definitely put a word problem. Okay, so the test that you guys are going to have next Friday, small test. Questions? We're okay? We're good? All right. I'll still keep the recording going. So this document right here, nope. That document right here, this was a test I gave many years ago. By the way, for those who know their Stanford football well, in 2013, Stanford football was incredibly good. We were a top 5 team. We went to the Rose Bowl. I was at that game. We lost to Michigan State. Not happy about it. But Andrew Luck had left. Christian McCaffrey wasn't there yet. We had Kevin Hogan as our quarterback. So this is like Stanford was favored by 31.5 points back in the good days when Stanford football was fun. Yeah. Anyway,
When they lost to Sac State.
Lost to Sac State, and actually, no lie, we played Oregon on a Thursday night. I had 8 tickets. I had season tickets, and I sold like 4 of them for like over $1,000 and paid for the whole season. So this is when times were good. Times were good back then. So yeah. Anyway, then I got married and had kids. No, I'm just kidding. Actually, that's true. I did. All right. Okay. Anyway, next up. So I have the solutions here. So the solutions for this one, if you know, it's all there. Anyhow, I would focus more. I mean, definitely do the 2013, 2014 one, but the 2015, 2016 is going to be more like what to expect next Friday. So I'm going to do a question like number 1. I'm going to do a question like number 1. Well, I'll give you 2 conic sections. That one's a circle and that one's a parabola. I'm going to ask you to solve the system algebraically. I'm going to ask you to rewrite the equation by completing the square. I'm going to ask you to graph them and find the points of intersection. So there'll be one question like that, for sure. Then there'll be a question, probably like 2, 3, or 4. I'm not going to say which one, but something where you have to write an equation, or you have to answer something about an ellipse or hyperbola or parabola or circle. So something like 2, 3, or 4. I'm not going to say exactly which one. And then there'll be a word problem, like 5 or 6 here. There'll be a word problem. 6 is similar to what we just did, but it's different. It's good. I don't have the solution key for it. I'll make it. Maybe I'll work on while you guys are working on this. There's not going to be a true or false question, so I'm not going to ask that, but it's just good to do anyway. So basically, the test will be half of this test. Definitely like number 1, something like 2, 3, or 4, and something like 5 or 6. So solving a system of nonlinear equations, you have the graph and find the points of intersection. Something like, you know, here's like some information about parabola or whatever, like maybe some characteristics of it, write me the equation, blah, 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 and then the word problem. So 3 questions only. I'll put some details in Schoology as well, just to say, here are the questions to expect. So again, I don't have the solution key for this. I'll try and make it today, or if not, later tonight, if I don't do it today during class. So, all right. I think that's all I want to say. So I want you guys working on this for the rest, but we do have a homework check-in. Let's do that first. And then you guys get to work. And this right here, I'll have a video ready for the first part of parametric functions or parametric equations. I'll have that ready by this afternoon. So check Schoology for updates later today.